here's my assignment 5. Okay, starting with a run through of my classes. Sum of leaves, I have if the size of the binary search tree is 0, then it will return 0 since there's nothing to sum. And then starting with the root, you go through the left, and if the left and the right are both null, that means that is like the leaf since there's nothing past that. So it will return that amount. And then I have two little holder values left and right. And then this is a reoccurring thing in almost all of my methods. So starting the root, you have either get left or get right. And if it's not equal to null, then we have a new node made with the binary search tree, which is set to root. So that way we can take root and get the next left, which we then use that left counter to recursively call the method again. And then the root is then set to the node to move on to the next spot, which is the exact same for the right, but it's just starting with the right. And at the end, add them together to get the sum of all of the leaves. Sum of the interior is very similar, except I have the holder value. I don't know why I just had the thing go off. I have the holder value sum left and right. Again, size is 0, nothing happens. It's literally like the same thing, except when you go down to the bottom, you're adding up sum left and right, because as you can see, like in this else statement, it's taking all of those values that are not null, aka the inside of the tree, and it's adding it on itself with sum. Print level order, which is just going to print the tree from like top goes across, blah blah blah, you know. So then if the root is null, it's going to return nothing. We have a linked queue, and then on queuing the root, and then when the queue is not empty, we have a new node made of the binary search tree, which is then going to have the dequeued value. And then we will print that node, which is basically saying like this is the value that we went to. And then we go to the left side, and then once it moves on to the right, and so it's gonna keep doing that throughout the tree and just print out each value. Print ancestors, which is gonna it takes in a specific value that you choose, and it will print upwards from that in the tree. So starting off, found is false. Found is the target value, whether or not it's in the tree, which we don't know right now. So the method, the tried and true, root get left is not equal to null, and then we're going to take that the node, set it equal to the root, move on to the next value, either right or left, depending on in the method. We're going to recursively call that target again, starting with the new the moved on value of that root, and we're going to get the info, and it's basically going to print it out. Okay, and then count single child nodes, returns as an int. I have the counter value, which as you can see, root equals null, there's nothing there, so it's 0. So this is going to take if it's left but not right, or if it's not left but it is right, adds to the counter because that it's a single child. And then moving on more specifically, call the left if it's not null, and then we're going to hold it and shift it over to the left by declaring a new node and then calling the get left. Add that counter and also calling the method recursively to continue counting, and it will eventually call the counter. Onto my driver. So here we have my new binary search tree. Not a very creative name either. Going down because I just added it to the bottom of the method. Here we go. Added a couple values to create my tree. We have this integer, which is the sum of the leaves, sum of the interior. Here, let me also print. I'll just have them print all at the same time. Okay. No, that should work. Okay. So, some of the leaves 22, some of the interior 23. print level order, printing everything in here, and then print the ancestors of 2. We've got 3. I added that exclamation part before I put in the print line, and I just realized I forgot to take that out. That's my bad. So when we're doing the count single child nodes, it's marked by an exclamation point now. Thank you for listening.